Good evening, children. Okay, so this particular problem, we solved it earlier under the video, which is for frictional force. Yes, okay. So while I solved this, and I was also showing the same thing in the classroom, and what happened was one of the students had viewed this video, and he said, "Sir, I did it by a different method, but I am getting an incorrect answer." Okay, let me show you this method. So what is the kind of misconception he had? Let me redo this problem once again. So we did it by a graphical analysis. So what happened was you applied a force of 0.5 F. Until 0 to F, the object did not move. But when you apply a force of 0.5 F to F, then the object started to move. Okay, this is what we have. So then what I did was I just plotted a graph of force versus displacement. And as a result of this, I got a graph like this. Okay. And when we got this, we found out what is the area. The area of this trapezoid is nothing but half D into A plus B. So we substituted this. Now this guy, what he did was, let me show you what he had done. He took up, okay, he has watched the video and he made a mistake like this. Then he said, "Sir, your concept is not always right. There could be a difference. If suppose if I plot a graph of X versus F, what was the earlier case? See, this was force along the y-axis and displacement along the x-axis. That's what I did. Okay, but he said, if I'm doing like this, I'm getting an incorrect answer. Now let us see what he has done. So he said that, see, from x equal to 0 to x equal to 0 to something like x equal to x. So initially, sorry, from f equal to 0, from f equal to 0 to f equal to 0.5 f. 0.5 f. There is no displacement according to this. See, so the object does not move. The object does not move until the force exceeds 0.5 f. Then after that, the object moves by distance x. So which means what he has done is he has taken like this. And the object moves until a distance x. And then, so this is my distance x over here. You get a triangle like this. Okay, this is your f. This is your x. And then he said, "Sir, I took the area of this triangle." Okay. So as a result of this, I get the area as half into 0.5 f, half into base, which is f minus 0.5 is 0.5 f multiplied by x, which should be equal to 0.25 fx. So your answer should be A. I immediately got taken back. Now, how come if you're changing the axis, something should change? It's not possible, right? So then it took me some while. Okay, I just looked into it. And which area he has to take? Should he take this area or should he take this area? Now he should have taken this area, right? So this is the misconception. Okay, so it is the area which is made with the x-axis. So in the previous graph, what did we have? See, the previous graph, that way this was your f, this was your x, and we got a curve like this. We got a curve like this, and we found out what is the area made by the x-axis. Here also the same concept applies. We did not use something like this here. We did not take up this one. If we had taken this one, we had got this one, right? So therefore, we need to take up this area. Now let us take up this area. So what is that you get once again? This should be half multiplied by, what is the d here? D is x multiplied by, what is the value of these two parallel sides? One of them is 0.5 f, 0.5 f. The other one is 1 plus f. So this value would be x into 1.5 f divided by 2, which should now be equal to 0.75 times f. 5f into x, right? F into x. Did we get the same answer? Look at this, right? We get the same answer. Okay, this is a misconception. So whenever we look at the area, some of these shapes that we get here will be very familiar, but we should not get confused. Okay, we should see to it that we are arriving at the answers correctly. Thank you, students, for watching this. So in the next video, we'll see some more. This is an extension of the previous video. Okay, thank you.